Okay, so the design documents are ready for pickup up here at the end. If you submitted a draft of that, hopefully you did. If you did not submit a draft of that, hopefully you've played catch up over the weekend. Because if you haven't thought about your design, this is not something that you can wait till the last minute on. It's pretty straightforward, especially if you read the documentation and bring in a library to do most of your work for you. But it's still, I mean, it's new to you, so it still needs some time and iteration. So hopefully you've got a good start on the assignment that's due on Friday. The one major thing that we saw with the design documents, and we'll be posting about this later with various things, was that people tried to take a shortcut, and they simply just copied, say, one of the student examples from a prior semester. That's not what we're looking for. All right, we're not going to ding you on plagiarism at this point since it's just a draft, but we don't want to see that again. And we also don't want to see, like when I gave you those templates, I just put in like a table just as an example, or an image as an example of how to include an image properly with, you know, the captioning and stuff and stuff like that. We never intended for you to keep those in there. Those should not be in your design document. Other minor things that we saw was, you know, people using definitions people putting definition. And some of the student examples that we've given you they're not perfect. All right, there are still some problems in there, so you shouldn't take everything as gospel from them. One of the things that you shouldn't take it was pointed out to me that one of the student examples actually has an extensive definition, and they define every little tiny word. Remember, your intended audience is a technically competent audience. Say somebody that's already out there, so you don't need to define simple stuff like object-oriented programming or Java or things like that. Those can be completely omitted because anybody who is in a technical field will know all that stuff. Now, if there's domain-specific stuff like you're writing a financial system and you need a definition for this account that's only recognized at the company that you're building the system for, that's when you put in a definition. When you've got domain-specific knowledge that needs to be defined because a general audience or a technical audience doesn't know what it is, that's when you put in those definitions. Abbreviations, of course, you can go ahead and put those in. XML, most people will know what that is, and a technical audience will know what that is, but it's okay to keep those kind of things in there. You'll note that the CS1 book I used last semester and it might be a good resource for Java if you're still struggling with some Java issues, has an extensive glossary and an extensive abbreviation glossary. So even though if I find an interesting term and I want to include it in that book, I usually do. Some of the stuff has nothing to do with CS1 specifically. It's just in the tech world, right? So as far as the main lecture goes here, today we're going to talk more about inheritance because that's what you'll be working with in lab tomorrow. You'll be given a system already that can benefit from inheritance, like we saw last time. I had a savings account and a checking account, and there were some commonalities between there, right? Everything. So what we did was we promoted those up to a superclass called just generic bank account. We've got an account ID, a balance, and an owner, right? I also took the liberty of making everything private. Okay. So now let's go ahead and continue from there. Let's go ahead and revisit the checking account class here. The checking account class, again, extends the bank account class, meaning that it inherits everything from the superclass, right? Let me go ahead and jump over to the savings account here, because already there's a problem, right, that's been introduced by us promoting these three fields up to the superclass. Remember that they get annual earnings. That formula used the balance times the APR divided by 12 over 12 months, et cetera. This annual percentage yield formula, who cares about that? What I care about is I have access to the APR because the APR is defined in this class. Even if I made this private, good encapsulation, keep everything private until you have a very good reason not to. And now maybe we do have a very good reason not to, because what about balance? I don't see a balance in this savings account, even though I defined it up here in this bank account. There's the balance right there. Why don't we have access to it? And in fact, the savings account is inheriting that. The savings account does have a balance. The problem is up here in the superclass, what have I done to its visibility? It's private. So even though you're inheriting it, you can't see it. So one way that you could fix this is by changing the visibility to protected. Remember that protected allows subclasses to see those things. And now if I jump over here to the savings account, you'll see that the compiler error has gone away here. Because it always inherited it. It always had a balance. It's just that it couldn't see it. Now, again, one principle of design is to keep things as closed as possible until you absolutely need to. Well, this might be a case where I say, okay, protected, now I do need to see it in the subclass. And maybe I'll also need to see the owner in the subclass, so make that protected. And maybe the account ID, I need to see that in the subclass for some reason. If not, then maybe I can go a different route. That different route would be allowing access, public access, through getters and setters. Good encapsulation, remember. So what I'm going to do is, and you can't see this, but it's on the other screen. I'm going to go up to source, generate getters and setters, right? And I'll go ahead and select all the getters, generate that. Right? Now, all of those are public. I have allowed access to say the balance here. I've allowed access to the outside world for this instance's balance. And in the subclass, again, I can't see it because it's private, but now I can access it through its getters. Get balance. Right? So, two different design ways of achieving the same thing. I need access to it, but I only need read access. So you can either make it protected so that the subclass can see it, or you can still, you can still make it private in the superclass and access it through getters. Right? And note here, I still don't see a get balance. Where is that get balance method? It's up here in the superclass. Each one of these three methods is inherited in the subclass. So by writing, I don't have to rewrite these things for checking account. Over here in checking account, I could say return this dot get balance. And it knows about that thing because it's magically inherited it from the superclass. Obviously, I don't want to do this because the get annual earnings on a checking account is 0, at least for this. Okay. All right. So that's, in general, by the way, my own personal opinion is this is the way that you should go. As long as you're consistent about your design and as long as you just have a justification for your design, go ahead and go for it. I think that this achieves our goal of allowing the subclass to see it, and in fact, it achieves another goal of allowing everything to see it, but not everything to modify it. Okay. All right. Well, that is a pretty good start there. So I've got all of these things. Now I actually want to work with it. All right. So here I've got a demo. Let me go ahead and create an Xmas account here, and I've already pre-done this. I want a savings account. That savings account ID will be ABC001, right? It'll have a balance of $1,000. I'm the owner. I created me up here. And I've got a 2% annual percentage rate for my savings account. Obviously, this is not working right now because we've got a compiler error. And you can't see it very well, but it's complaining that the constructor doesn't exist. Right? What constructor do you see over here in the savings account so far? Do you see a constructor? There is none. And if, again, like a lawyer, if you don't provide a constructor, one will be provided for you. The default constructor. Right? So if I want to, I can go ahead and go savings account foo is equal to new savings account. There we go. And that's how I can actually create an account. Well, obviously, I don't want to do that. I want to be able to provide the ID of the account, the balance, who owns it, and the APR for that savings account. So what I need to do is I need to go over here to the savings account, and let me go ahead and generate a constructor for this. And again, I'm just going to go up to source, generate constructor using fields. Well, the only field that it sees is APR, right? So if I do that, well, now I've got my constructor, but there's no way to provide the things that I wanted to over here in the demo. I wanted to provide, let's go ahead and get rid of this. I wanted to provide, again, the account name, the account number, the balance, the person who owns it, and then there's the APR. But as it's designed right now, the only thing that I can provide is the APR. So to solve this, what we need to do is we need to have the subclass interact with the superclass. Let me go up to the superclass. You'll note here that I don't have a constructor either. So let me go ahead and generate that constructor using, again, source, constructor using fields. And now I can see things like account ID, balance, and owner. I'll go ahead and generate that. I want both of these, right? I want the ability to provide the account ID, the balance, the owner, and in the subclass, the APR. So to do that, I'm going to make a change here. I'm going to take these three things, and I'm going to come over here to the savings account, and I'm going to add them, because that's exactly what I want. Let me go ahead and increase the size here. I want a constructor to provide the account ID, the balance, the owner, and the APR. And now I've got all those things. But of course, you can see that, well, there's no account ID. This dot account ID is, not get account ID, but account ID is equal to the parameter account ID. I can't do that because, again, I've chosen to make it private. It can't see the account ID, so it can't set it. That's okay because we have another constructor to do that. We have a constructor that takes an account ID, a balance, and an owner, and we've got that in the superclass. So in the subclass here, again, it's subclass because it's extending the bank account, I can go ahead and pass off those three things to the superclass's constructor. Right? And the way that we do that is by using the keyword super and treating it like a function that you call and passing up the account ID, the balance, and the person. What did I call it? Owner. There we go. There. Now everything is right with the world. The checking account still has a problem over here, but we'll go ahead and fix that similarly. I've got actually a chain of constructors. When I create this over here in the demo, when I create this Xmas account and pass it in those four things, this constructor over here in the savings account is called. I'm passing off those four things. It takes the first three of them and then passes them up to the super constructor so it can do what it wants with them. And the APR, it ends up setting it here. Right? And then again, the way that good encapsulation, you want to control access to your variables through constructors, getters, and setters, because that's where you're going to do data validation. For example, what would be an invalid APR? A negative value, okay. Or I don't know if 0 is a negative. Those are all business rules that you then have to go and say, well, what is a valid APR? When you're designing a system, you go to the people who are in charge of your stakeholders and you say, what is a valid APR? Can we have a negative APR because you actually charge them interest to store your money in their account? Right? And if they say, oh, yeah, that's a good idea, and then they start screwing all their customers, then it kind of backfires. But you can do basic validation here. If the APR is, say, less than 0, then you can refuse to construct the object and throw a new illegal legal argument exception. Right? APRs cannot be negative. There we go. Or maybe you can change this to a big D double, and now you have now you can validate whether or not they gave you an actual value, a null value. Right? I'll keep it as a primitive type here, though, because I don't want to have to deal with that. Right? All right, so that's great for the savings account. What would the checking account look like now? Right? Well, now when I go up to source and constructor using fields, let's see, does it allow generate? Nope. Unfortunately, it's not going to do it for. Oh, yep, it did it for me now. Why? Because it saw that the super constructor existed. And so the super constructor, it's able to say, oh, okay, you probably mean to take all four of those things and kick that account ID, the balance, and the owner up to the super class here. And again, we use the keyword super. We don't say new bank account, even though we could do something like that syntactically. Well, it would be invalid syntax, but it would make sense syntactically if Java allowed that. We simply just have a super keyword that I want to go ahead and access the super classes values or the super classes constructors or the super classes methods. Super dot get account ID, right? I don't need to do that because it's inherited. There we go. I can just go with a get account ID, and it's inherited that method, and so I don't need that super there. But I do need the super to the keyword to refer to the super classes constructor, right? All right. So everything looks good now. Let's go back to our demo, and now let's release all of these. Right? I've got 2 savings accounts and 2 checking accounts here, a Christmas account, a life account, whatever that is, a work checking account that I deposit my work checks into, and then my secret checking account that nobody knows about that I launder money through or something. Right? All right, so I've got a pretty good collection of banking, financial transactions, or financial accounts here. I want one more. Right? Let's go ahead and make a bank account. What? I can't put a question mark here. Is equal to new bank account. Okay, well, what does that take? Well, first of all, the default constructor is gone. The only constructor up here in the bank account takes an account ID, a balance, and an owner. Right? So let's go ahead and give that to him now. Again, what? Bank account, that's the what 001, make it look like an account number. There we go. Me, I'm the owner, and we'll go ahead and put in $1 million. There we go. All right, and you can go 00 on that. And it's still complaining why. Did I do the order wrong? Oh, the balance and then the person, sorry. So the balance should go here, and then the owner. There we go. So I just gave myself a bank account with $1 million in it. Does that make sense with the design that I've gone with right now? I've got a checking account. That makes sense because checking accounts are a real thing in the real world. All right, you can write checks out of it. They have monthly fees the way that we've designed it. Likewise, savings accounts are a connection to the real world. Savings accounts have balances and APRs, and you earn interest on them. Is there such a thing as a generic bank account in the real world? Maybe. I'm not a financial person myself, but I highly doubt that there is just this generic bank account where you throw money into it, and it's just a black hole where you can put money into it, maybe take money out of it, but we call those savings accounts, right? So is there really a need to define the concept of a generic bank account? Well, there was a need to do so in my code because I wanted to reduce the redundancy. I want the account ID, the balance, and the owner, and in some sense, all of this functionality that I've defined here. Again, it's just a data container at this point, but all the functionality that I have right here, I didn't want to duplicate that. I don't want to violate the DRY principle, the don't repeat yourself principle. So from a design perspective, yes, it makes sense to create a generic superclass called bank account. But also from a design sense, we don't want this situation where you can actually create one of those things. So the idea of a savings account and the idea of a checking account, those are concrete ideas. Those have a connection to reality, to the real world. But bank account, that doesn't have a direct connection to the real world. It's not concrete, it is more abstract, right? It's an abstract idea of this general bank account. We can do that in our code by making this class abstract, right? Oops, what's wrong? Did I misspell it? Public, I think it goes before class, sorry. There we go. There. Now, that's the order. It didn't like the public class abstract. It wants an abstract class because an abstract is an adjective. So you put the adjectives in front of the nouns, right? It's an abstract class. Now, that didn't change any code over here. It didn't change any code over in the savings account. It didn't change any code in the checking account. But what it did achieve is it changed what I can do outside of the class. You'll note now, maybe you can't see it, but that is highlighted in red now, right? That is now a syntax error. And again, you can't read it, but it says you cannot instantiate the type bank account, right? You cannot create an abstract thing. You can only create concrete things. And so this is another aspect of inheritance in object-oriented programming. You can restrict what can be created and how they're, not only through a constructor can you restrict how things are created, but you can also restrict the things that can be created at all, right? It has a constructor, right? So you might think, oh, I can construct it. You can construct it by calling super in the subclasses, as long as this is a non-abstract class. But outside of the class, you can no longer do this. And so I've got I've solved all the problems of don't repeat yourself, but also I've designed my class such that you cannot create instances of this abstract idea, right? So this is no longer allowed because it's completely abstract, right? You could take this a step further, right? You could, over here and say bank account, you could make, say, an abstract function, right? So let's go with public abstract get risk ratio, right? Again, I'm not going to be a double. Right? I'm not a financial person, so I steal whatever ideas I can. But apparently there are stocks, there are bonds and things with ratings, right? This is a risky stock because it's up and down. This is a blue chip stock. In other words, it's a well-established company that has it's not going to be huge payoffs, but it's going to be, it's going to grow steadily or at least not lose value. But then there are risky stocks, penny stocks or whatever that you can invest in that are highly risky. In other words, there's a 90% chance that it's probably going to fail. But there's that 10% chance that if it goes off and they have an IPO, an initial public offering, and they get bought out by a big company, well, now your stocks are worth millions of dollars or something like that. And one way of measuring that is through a risk ratio. I think it's a beta measure, is it, with stocks? And of course, with bonds, you've got AAA ratings, AA ratings, and stuff like that. So there is the idea that accounts can have risk, right? Now, a savings account, checking account, those are all FDIC insured. So unless the federal government collapses, who knows, then they're not risky, right? Because they're insured by the federal government. They'll come in, take over the bank, and everybody's personal deposits are secured by FDIC insurance. So we could introduce the idea of a risk ratio or a risk number associated with this account. Maybe checking accounts, they have a risk of 0, but the savings account is actually in a money market or something that may fluctuate, and so it has a higher risk, right? So let's go ahead and go over here. Oh, actually, no, I'm going to start here, right? What is the risk ratio of an abstract class? Well, let's just say that the checking account, that has a risk ratio of 0. And for arguments purposes, let's just say that the savings account has a risk ratio of 0.5, okay? Those are concrete ideas with actual things that you can measure actual risks. But what about the idea of a generic abstract bank account, right? How do you measure the risk of something that doesn't actually exist in the real world? You don't. So instead, you make it abstract. Right? There's no way that I can say return 0.5. Not all generic bank accounts will have a 0.5 risk measure. Right? There's no way that I can return 0. There's no way that I can return null. Right? There's nothing that I can return here that makes any sense. So instead, what I can do is I can make the method itself abstract. Right? Because you're saying, I don't know how to implement this method. It depends on the type of account that you've got. It's either going to be 0 or 0.5. Or in the future, if you introduce a new type of account, an investment account, then you can actually bring in the beta measure that they publish in the stock market, right? But when you get down to a non-abstract class, that's when you have to start specifying how this stuff works. You'll notice now that there is a compiler error here. It's saying that the checking account must implement the inherited abstract method bank account get risk ratio, right? In other words, for me to actually use this, I have to define what that function does, what that method does. So public, what was it? Double get, what was it? Get risk ratio, cut, paste. There we go. Get risk ratio, right? Now for a checking account, that's going to be 0, right? Over here, I'll go ahead and cut and paste. Over here for a savings account, that's going to be, say, 0.5. Right? 0.5. Right, there we go. So I'm providing specific concrete behavior in the subclasses, and I'm making the superclass abstract so that it has a couple of advantages. First of all, if I know that every account should have some risk measure, I can put that up here in the abstract class. But I don't know how every single account will work by default, so I'll make that abstract and then require anything that extends that to actually implement those things. And those are called abstract functions or abstract methods. You can actually take this a step further and define what's called an interface. Right? So let's go ahead and create an interface here. Very, very quickly. I don't know. I don't know what's more. So I've got savings account. I've got a bank account. What's even more generic? Account? Okay. I honestly don't have any idea. All right, here's my interface. What is an account? An account should have an owner, right? Maybe it doesn't have a number, or maybe it does have a number, but it definitely should have an owner, right? So let me go ahead and put a public interface here, a public interface that returns the person that owns the account, get owner. There we go. Now, you'll note here, is there a body here at all? What if I tried to do this? Return this dot owner, right? Not get owner, but owner. There we go. It's going to complain. And the reason it's complaining is abstract methods do not specify a body. Where am I here? I have what's called an interface. So let's contrast this with the bank account over here. The bank account is an abstract class, meaning that you can't create instances of it. But at the same time, it's got public methods that are well defined. It's got a public method, get account ID, get balance, get owner, right? Get risk ratio, but that's abstract. Three of these methods have an actual body and an implementation that's provided. This one doesn't because it's abstract. An interface takes it a step further and makes it purely abstract, meaning that it only has the methods that everything that implements this interface should have. In other words, I cannot put an actual function into an interface. Now, an asterisk on that, as of Java 8, you can. They're called default methods. I will not get into it because it was kind of a mistake in my opinion. And the reason being that the whole reason that we have interfaces is so that they're purely abstract things. By putting default methods into it, we're making them not purely abstract things. We're making them abstract classes. So they introduced some additional complexity into the language in Java 8 that we won't get into, but you should know about them, right? But this is a purely abstract class. So let me go over to the bank account here, and let me add one keyword. It implements account. There we go. And it's actually happy about that from the start because over here in the account, to be an account, you have to have a public function that returns an integer, or returns a person, and is called getOwner. Well, guess what we have over here in the bank account? We have that very thing right here. So we're already implementing that interface. We're just declaring that we implement that interface up here. If I got rid of this, in fact, then it would start complaining. It would say, oh, where is it? Oh, I don't have to do it up here, but now it's complaining in the subclasses, right? So what I could do, so by putting it in the superclass, let me restore that, then the subclasses inherit it, and so they're happy now too. By getting rid of it here, that means that they're no longer inheriting it, and so it's complaining, and it says, wait a second. You extend the bank account, which implements an interface called account. You need a getOwner method here. And if you don't have a getOwner method, then it's a compiler error. I could put that down here, right? I could, oops, that's not what I wanted. I could put this. I could put that into the subclasses, and now it would be happy except for it can't see owner anymore. So I'm just going to kill two birds with one stone and put it into the superclass, okay? We'll revisit this in the context of, in fact, let me pull out my notes here. Unfortunately, I don't know where they are. I drew a pretty picture one time. Let's see, lecture is and OOP, and I think it's in OOP in Java. No, not that one. Here we go. Where is my pretty picture? I thought I had a pretty picture to show this basically. Where is it? I thought it was here. Maybe it's over here. Sorry. I put so much time and effort into drawing it. It'd be a shame not to see it. Here we go. All right. I'll go ahead and post these as well later on. These are just older notes when I did PowerPoint kind of stuff. Actually, let me go ahead and jump up here first of all. This is a simplified view of that. So we've talked about sets, we've talked about lists, we've talked about maps, right? And here's a clearer picture of what those actually are in the Java world. All right. The three things on top, the collection, set, and list, they're actually interfaces. They don't specify how a list, say a collection, works. It just specifies that a collection has this set of functions over here that you can call. You can, for example, in list, you can get the ith element. Right? In set, you can't do it because sets are unordered. Collections are iterable. In other words, you can put them into an enhanced for loop and iterate over the elements. So those are interfaces that guarantee that anything that is a collection is iterable. You can iterate over the elements because if you can't, then how do you get the stuff out that you put into the collection? Hash set, tree set, those are actual implementations of the set interface. And those are the ones that specify how they're actually represented. A hash set under the hood is using a data structure called a hash table. And a tree set under the hood is using a data structure called a tree that we'll get to by the end of the semester. But how they do things is not specified in the superclass. Only the interface, that here's a set, it's unordered, it doesn't allow duplicates, you can iterate over it with an enhanced for loop. It's what it is, not how it does things. Only in the subclasses do we start to provide those actual implementation details. Likewise, on an array list or a linked list, that's something that we'll get to very soon in the semester. Well, they're both lists, right? They're both lists, but one of them uses an array to hold stuff, and the other one uses a bunch of nodes to hold stuff. And they have various applications and various advantages and performance issues with them. But you have two implementations. One does one thing a specified way, and another does it in a different way. In other words, you have concrete ideas down here in the subclasses. You have specialization of behavior. This one does it using an array. This one does it using a linked list. But the unifying thing above is the idea of an interface. These are the things that a list has to have. You have to be able to get things by index. So you have to have a get with an int that's zero indexed, unless if you don't, then you don't implement that interface. And it's not a list. You can't treat it like a list. Here is a much larger, broader picture of those same things. Right? In between them, so everything in the green up there is an interface. Everything in the middle is blue. Those are abstract classes. And down here at the very lowest level, those are you can call them concrete classes if you want. They're just non-abstract. We've tree set, hash set, array list, and linked list. But in between there, that's where all of the specified functionality kind of gets moved up. For example, abstract set. Both of these sets down here might have some common functionality. For example, how it iterates over the elements, right? So if we can take that common functionality and promote it up here to an abstract set, then we don't have to write things twice, right? And those things get inherited. But I don't have all the details up here. This is just abstract. I know what should be done, but I don't know how it can be accomplished. Down here, I would have a hash table. Over here, I would have or I guess tree is over here now. I would have a tree data structure. Over here, I would have a hash table data structure. But the commonality gets promoted up to the superclass. And you can see that hierarchy all the way through. Now, at the very top level, the interfaces, that's where the diagrams, and you can see the lines there, that's where it gets a little bit more complicated, because you can actually inherit from, you can implement multiple interfaces. Multiple inheritance is something that is supported by some languages like say C++. It leads to some problems though. Java doesn't have that problem because it is a single inheritance hierarchy. But it does, meaning that if you look at every single class in Java, all the way at the top, there's only one, and it's called object, right? And this is why you've probably seen the big O object sometimes in Java. It's because everything inherits from object at some point. So you've got this big, huge, giant inheritance tree with everything in Java, but it all leads back to one thing, object. It's a single-rooted inheritance hierarchy. We'll talk about that in a moment here. But otherwise, at the very top here, we've got things that give it meaning, semantics. For example, iterable way at the top, or sorted set. A tree set is not sorted, right? Or sorry, a hash set is unsorted. In other words, if you put stuff in and then iterate over it, there's no guarantee that you'll get the same order. But a tree set is actually orderable. That you put stuff in according to a comparator, and then you iterate over it, it'll actually keep that order, right? Not that it's storing them in order, like A, then B, then C, then D. It's actually storing them in a tree structure, but when you iterate over it, it's guaranteed to give you that structure. But I don't want every set to have that property. So instead, I define that in an interface way up there called sorted set, and I say that a tree set is a sorted set, but a hash set is not sorted. Right? Likewise, some things like, for example, an array list. That uses that has random access because it's using an array under the hood, meaning that you can jump to a particular index, all the arrays that you're used to. That has random access because you can. They're all stored contiguously. You can immediately jump to the memory location if you know the index. It's the index times the number of bytes in each one of those things. But a linked list doesn't work like that. So I define what it means to have random access way up in the interfaces, and I say that an array list has random access, but a linked list doesn't. Right? So by creating this structure, I have a lot of flexibility. Right? I can adhere to the DRY principle, don't repeat yourself, by having actual concrete implementations in abstract classes. But then I can also have purely abstract ideas of this thing is a sorted set. This thing is a set. This thing is clonable or whatever, right? And I can keep all of that abstract way up here at the interface level. So a couple of different ways of achieving basically the same thing with different consequences to each one of those things. Right? And you'll explore that more further in tomorrow's lecture, or no, sorry, lab. Okay. All right. So let's see. Find my place. Sorry. All right. So to summarize what we've looked at so far in inheritance, right? Basically, you can create more generalized superclasses and collect common functionality and state in them. And then you can create more specialized subclasses that inherit from their parent classes. All right. Regardless of the visibility keyword, everything in a superclass is inherited. Making it private means the subclass cannot see it. Making it, what was the key word so that the subclass can see it? Protected. Making it protected means the subclass can see it. Right? What else did we look at? It inherits methods, it inherits functionality. You can also have abstract classes. You can make superclasses abstract to prevent instantiating, that is, constructing instances of them. Right? Abstract classes may have abstract methods. Right? That is, methods that do not have a function body, but that non-abstract subclasses must implement. And again, you can take that a step further. Interfaces, or uninterface is a pure abstract class, right? It is it only defines method signatures, no function bodies at all, right? It's a purely abstract kind of idea. Right, there we go. Again, some other keywords here. To create a subclass, you use the keyword, what was it again? Extends, right? To implement an interface, you use the keyword implements. Right? It is implement. There we go. Right? Any class may extends at most one other class. Right? You can only inherit from one class, so that you can't inherit from two classes. Right? I can't have a bank account and a routing account. Right? I can't have two things that inherit. My savings account has a routing number usually, right? But it can't inherit from two different classes, a routing account and a bank account, right? You can't do that in Java. In other programming languages you can, but it leads to severe potential problems. So you can extend at most one class. However, you can implements multiple interfaces. Right? And the classic example of this, I don't know, I think it's in my notes somewhere, but I should have fired this up so that I can draw stuff instead. There we go. Just needed to be woken up. All right. Here we go. Get out the big Sharpie here. All right. So the class, let me go ahead and move over to this, I guess. .cam, there we go. All right. So let's just look at the situation where that we've already developed the bank account. This is called basically called a UML diagram, Unified Modeling Language Diagram. Don't worry about that, though. For your design document, you'll have to worry about that, but use a tool, right? That is, if you've got the code base already, there are plenty of plugins out there that will take your code and generate these diagrams for you, so that you don't have to sit there and and create these diagrams by hand. So here's my bank account. The way that we look at this is that savings accounts and checking accounts, there we go, they are children. They're child classes. And we've got the parent up here. We'd always draw it from the parent to the children downwards, just like a family tree, right? Most of the times the arrows go back up here, and the arrow goes back up here. And a savings account, this relationship should be seen as an is-a relationship. All right? Meaning that a savings account is a bank account. All right? Likewise, a checking account is a bank account. All right? But what about the relationship downward? Is a bank account necessarily a savings account? No, because what if I create a savings account? Well, it inherits from a bank account, so it is a bank account. But if I happen to create a checking account, would you say that that's a savings account? No. But it is a bank account. So the is a relationship only goes upwards. The inheritance is only one way. All right? I'm going to have to remember the terminology for that. Contravariant, covariant, and invariant, but we'll talk about that next time. All right, so that's the picture that we have so far, right? We also have implements, right? So we've got another one up here. What did I call it? Account? Okay, account. So it's also transitive. If I can say that a savings account is a bank account, and a bank account is an account. Therefore, what can you say about a savings account? It is a account. Right? So if these things follow this relationship, then I can treat a savings account like a bank account with no problems, and I can treat a bank account as a savings account, or as just an account. But I can't treat them downward. Right? The idea here is that what if I've got multiple accounts like I do in my example? How can I store them all in one place? I might be able to create, like, say, two collections, right? One with all my savings accounts and one with all my checking accounts, and then keep them separate. That seems kind of odd, right? Because I want one place that I can keep my entire portfolio and add up all my balances for me. Okay, and so that kind of introduces the idea of polymorphism working with inheritance. It's called subtype polymorphism. Okay, let me go ahead and go back to my example here. There we go. And let's go ahead and go back to this demo over here. All right. Now, I'll leave that in to show you that you can't do that. My goal, or here in comments, goal, is to collect all my accounts and sum up their balances. Okay? So, well, first of all, what could I do? I could do something like this. Total is equal to 0. Total plus equals Xmas account dot get balance, right? Total plus equals, what was the second one? Life account, right? Should I be going down this path? Is that that's violating all kinds of design principles here, right? So first of all, let me go ahead and split this out into another function. Public static double sum total of all my accounts. I'll go ahead and keep it in a list, let's say, a list of checking accounts. My checking accounts. There we go. Let me go ahead and increase the size here. So let me import this. All right. And of course, it's complaining that I haven't returned anything yet. So I'll create a double total. I'll set it initially equal to 0 and return that total. Now what I want to do is I want to iterate over each of these checking accounts, and I want to add that to the total. So I could do a traditional for loop here, but we're in Java. We should not think of in low-level kind of C stuff anymore. We should think in terms of enhanced for loops or for each loops. For each checking account, A, in the collection my checking account, right, counts. There we go. Total plus equals A dot get balance. There we go. And I'm summing those up. So let's come down here and let's get rid of this now. Double total is equal to, I need to call that function. So sum total of all my checking accounts. So obviously I need to create that list. So list savings accounts of my, checking. Was it checking or savings? It's checking. There we go. Here's my checking account down here. My checking accounts is equal to a new array list of likewise checking accounts. Then my checking accounts will go ahead and add my Xmas account. And I will add my, what was the other one? Life account? Life account. There we go. All right. And then I'll go ahead and report the total. System.out.println total. All right. No need. What's it griping about now? Oh, sorry. Those are savings accounts. All right. So I need the work account and the secret, my secret checking account. There we go. Oops. There we go. Now I'm summing up all the checking accounts, and it's still complaining. Why? Oh, because this is a savings account. There we go. All right. And I should have called them. Wait, no. Ah, darn it. Okay. Anyway, there's already a type mismatch because this is a terrible design. All right. What is the limitation here? We'll just say that these are all my save. It's still complaining. Darn it. All right. So I need to change this back to checking account. And those are checking accounts, so I can call that. And everything's fine except for. Oh, thank you. Maybe I was just confused that it hadn't imported that. All right. Checking account, checking account, checking account. All right. Everything matches now. Thank you. All right. So what should this total be? It's $125 and $500 at $625. Yeah, don't worry about those. $625. Right? Well, that takes care of my checking accounts. What do I need to do now about savings accounts? Cut, paste, change to savings account. Call this a savings account. Am I doing the correct thing here? Or is this should be sending off red flags, right? My savings account and savings account on this checking account instead. There we go. And then return the total. What's still wrong? Oh, sum total 2. Let's do that way. There we go. In fact, it wasn't even allowing me to call them the same thing. Does that look right? Two functions that do the exact same thing, one for checking accounts, one for savings accounts. In fact, the only line difference is on line 19, right? Or line 19 and line 10, respectively. Right? Does that look right? No. I'm violating again. What am I violating? The don't repeat yourself principle, right? A checking account is a bank account. A savings account is a bank account. All bank accounts have balances. So I'm going to make this generic. It's not just going to be checking accounts. It's going to be a bank account. And instead of calling it my checking accounts, it's just going to be my accounts. Right? There we go. Change that, and change this from bank accounts or checking accounts to bank accounts. Now I don't need this. Right? Now what I can do is where is it? Sum total, bank accounts. Okay, and you are griping because. Okay, it shouldn't be complaining to. Okay, here I know how to get this to work. Whatever extends. Okay, that'll work, but I don't want to do that yet. So it's still not working down here because this is an array list. This is a list of checking accounts, right? And it doesn't take a list of checking accounts. It takes a list of bank accounts. So what I'm going to do is I'm going to change this list to bank accounts. Bank accounts. There we go. And even though I'm still calling it my checking accounts, and I'm only adding the checking accounts, the work checking and the secret checking, I now have a function that applies to either one because I can do the same thing for, let's redo it all, my checking accounts, my savings accounts instead now. Savings accounts, my savings accounts, my savings accounts, and it'll be the Xmas account and the life account now. Right? And so I can report two of these things and get rid of the duplicate there. And so it'll be $625 and $1,125, which is 1,000 plus 125 right here. Right? But I can take that a step further, right? I've got one function, one method that operates on all types of accounts. Why do I need two lists, right, to separate out my types of accounts? I don't need to do that, right? I can call this my accounts instead. And I'll add the work account, the secret account, get rid of that and that. I will add the Xmas account. I will add the life account. And now I can get a sum total of all of my accounts with one single collection. and one single method. And now what was the result before? I forget what it was, but now it'll be those two numbers added together, right? By creating this hierarchy, I can treat subclasses as their superclasses and simplify my code. I don't need to make a distinction between a checking account and a savings account because they're both bank accounts. If all I need to know is what's the total of balances, well, then I can treat them all as this generic, more generalized type. And that's called subtype polymorphism. It's one of the advantages of creating an inheritance hierarchy. You can treat everything the same, right? And you don't have to have a separate collection for one type of thing and a separate collection for another type of thing, and two completely different code bases for the same thing. You can keep it all unified and keep it as generic as possible. In fact, whenever you're writing a function like this, you should keep it as generic as possible. Okay? It's just bank accounts. Or I could say that they're all accounts, but then it's going to complain about that because does an account have a balance? No, an account only has get owner. So make things as generic as possible, but not too generic that you lose all of the information that's required to actually do what you're trying to do. Right? Down here, again, I don't have access to balance anymore because if this is simply an account, to be an account, all you need to do is have this get owner method that returns a person. You see no reference here at all to a balance. It's only when you go down to the bank account level that now you have the concept of a balance. And so you do need to treat these as bank accounts instead. Bank account. There we go. All right. So again, to review, creating inheritance hierarchies allows you to organize code and provide and eliminate duplication, and allows you to write more generic code that operates on more general types. Right? So, not that you, let's take the last 15 minutes here and talk about the nitty-gritty details. And I'm glad that I still have this up. All right. Let me go ahead and go over here to savings account. Let's focus on the get annual earnings. No, checking account. Yeah, we can focus on either the get annual earnings or the risk ratio, or whichever one you want. Let's go ahead and look at the risk ratio here. How does this stuff actually work? How does inheritance actually work? I'm going to go ahead and move over to the .cam again. And okay. So when we create a bank account, it has a specific type. When I create, and I'll go ahead and go with shorthand here. I'll go ahead and write it out. Bank account A is equal to new savings account. Right? And I won't worry about the details here, whatever. What this does is this creates in memory an actual instance of savings account. So let me go ahead and write in memory here as A is referring to this object right here. This is a savings account. Now think about memory. What is stored in memory? Data is stored in memory. So one of the things, what does a savings account have? It has an owner, right? It has a person. It has a balance. What else did it have? APR. Right? And it had a couple of other things that I won't worry about at this point. This is just data, right? What else defines an object? Methods. So it also has methods in here, except it doesn't have the code for methods. It has a reference to code for methods. So for example, let's say that it has a get risk ratio. Right? This is a function that is part of this class, but it's actually a reference to the actual function get risk ratio And the savings account returns, I think, 0.5, right? So it returns 0.5, right? That's this code right here, okay? What happens when we go A, because it's just a bank account, when we go A.getRiskRatio, what happens is, again, message dispatch, a signal is sent to this the actual object here, and the object says, well, when I was created, my reference to this function was actually over here, so I will go ahead and call that function for you and give you that result, 0.5. What happens when you create a different type of bank account? B is a new, and the other one was checking account. Right? And so in memory, that creates B as a reference to another object. And it has a person, it has a balance, it has monthly fees instead, right? And again, this is just data. When it got created, though, it also has a get-risk ratio, right? But it's not a reference to this one over here because we overrode that method to provide different behavior. It was returning 0 instead. So this is actually a reference to a different function in memory, get-risk ratio. And this one returned 0, okay? So when I go A.getRiskRatio or A.getBalance, it dispatches it to the correct method. When I call B.getCheckingAccount, it dispatches it to the correct method. Two different methods in code that are assigned when you create a new instance of it. When you create a new checking account, the constructor says, okay, get-risk-ratio, you need this function over here. Right? But when you go new checking account, it says, okay, get-risk-ratio, that's this function over here. That's how inheritance actually works. These things are called V-tables. This is V is short for virtual table. And it's because it has references to virtual functions. This is an actual function, this is an actual function, but this is not a function. It's a virtual function that then dispatches its behavior to another function somewhere else. And you don't need to worry about any of this because it's all done through inheritance for you. Right? You don't have to, imagine in a programming language like C, where you don't have inheritance automatically. If you have two different types of checking accounts, what do you have to do? This is not even in the picture. You have get-risk ratio. You'd have to rename this. Get checking account risk ratio. You'd have to call this one get savings account risk ratio. And then you would have to actually manually call each one of these depending on what you're trying to deal with. You couldn't create two generic bank accounts and assign them to different types. You'd have to actually have a savings account and a checking account, and then you could never treat them the same. The advantage of inheritance means that you've got virtual tables that takes care of all these details for you. Right? And again, these are virtual functions because they're stored in a virtual table, or a V table for short. What if we don't want this? Right? What if I want to prevent you from doing this in my design? Go back to, there we go, and there we go. All right. So let's see. I'm down here in savings count, public person, get person, or get owner, sorry. Return new person, me. I own every savings account in the entire institution now, right? Is that a good idea? Nope. I've overridden what this function does. Up here in the bank account, well, it returns the owner that you created this with. What I'm doing is I'm short-circuiting that, and I'm saying I don't care what you created me with, just return me as the owner, right? I want to prevent this. I don't want you to change what it means to return an owner. So what I'm going to do is I'm going to come. This is a virtual function, right? It can be overridden in the subclass, and that is the key term there. We override it in the subclass, and to change, the get owner to change what it does, right? And I can do that by simply just providing the function, and it changes it, right? If I want to prevent that, I need to make this a non-virtual function, right? It's a virtual function because it's created with a virtual table up here. If I want to say, no, in the subclass, you cannot override that method. You can't change what that method does. Well, you can make that into you've seen this keyword before, but in a different context. You can make it final. Now look over here in the savings account. Trying to change it so that the get owner returns me all the time, you can't do that anymore because it's not a virtual function. It's not being created by this v table anymore. No matter what you do, it's always going to refer to this function and this function only that returns the owner. Right? I'm taking away the ability to override it in the subclass by making it final. Right? The final keyword makes functions non-virtual, so you can't override them at all. Where else have you seen the final keyword in Java? Constant variables. Public final int, or public final double pi is equal to 3.14159. Now putting that final in front means that nobody can change the value of pi. Same idea here. When you make a function final, or a method final, that means that nobody can change what the function does. So final on a variable, you can't change with a value. Final on a function means that you can't change the function, the behavior. Right? You can go a step further in a third context in which let me go ahead and get rid of this. You can no longer do this because it is a final method. Well, you can also make a class final, public final class. Right? Now, it's not going to have an effect here because we're not subclassing the savings account, but I would be prevented from subclassing the savings account into savings account type A and savings account type B. To see this actually in action, let me go up to the bank account here and make this a final abstract class. And it's going to complain because, well, there's no point in defining a final abstract class because you can't create it. But let's go ahead and take public final, and then we'll go ahead and take this away. There we go. And now the subclasses are complaining about that. Bank account, you can't extend bank account because it was declared final. So by making a class final, you can't change what that class does. Here is a perfect example. What if I was allowed to change the way that a string operates? Right now, strings are immutable, right? You can't, once they're created, they can't be changed. What if I subclass string so that you can change the contents? That breaks all of your expectations on what Java does. Even worse, what if I change the way that an integer works? An integer, you have a very clear concept of what that is, that an integer plus an integer is an integer. 10 plus 5 is equal to 15, right? What if I changed it to create a subclass of my awesome integer such that 10 plus 5 is now equal to 8, right? That breaks your entire concept of what an integer is. And by making something final, that ensures that you can't do something like that. Let me go ahead and undo all this stuff. I'll keep that. Let me go ahead and change that back to abstract so that everything is fixed. There we go. Let me go ahead and try to do that. Let me go ahead and create a new class, my integer. There we go. That, I don't know, extends integer. So that when you call, say, the toString method, public string toString, there we go. I'll go ahead and return, nope. Right? What if I change the toString method of the integer class, or of my integer class, so that instead of printing out the actual integer, it just printed out nope. Right? Is that a good design? Right? That completely breaks all of your expectations on how Java should work, or the language itself, whatever language you're using, should work. So consequently, I can't do that. In fact, it's telling me that I can't do that right here. The type myInteger cannot subclass a final class of integer. All of the built-in types are made final so that you cannot change them. You can't change fundamentally what a string in Java is. They've designed it so that you can't do that. You can't change fundamentally what an integer is. You can change all your classes as much as you want, unless you don't want to. If you've got a class that is final, there should be no subclassing of this class at all, then you can go ahead and make that final and prevent others from doing so that they don't break the expectations that you're putting into your program. Okay? And again, that's all virtual functions. So how inheritance works, right? When you instantiate a class, a virtual table, or vtable for short, is created with references to specific functions, right? So that when you invoke those functions, it actually dispatches them to the correct function for that class, regardless of how you're referring to it. You can make methods or classes final in Java to prevent overriding or subclassing. Right? In other words, they will not be virtual. Right? And so that's another design principle that you can explore tomorrow in your lab. Try a few things. Like what happens if I make that final? What happens if I make that abstract? What belongs where? How should I design this hierarchy? What are the questions you should ask yourself when designing a hierarchy are, here's one class, here's another class. What are the commonalities? If there's a commonality, then you need to promote that up to the top. And then you have to ask yourself questions like, all right, well, does it make sense to be able to create an instance of this superclass? If so, then okay, I'll go ahead and leave it. If not, then I need to make it abstract. Or if I need to take it a step further and make it really abstract, purely abstract, and define an interface, right? And those are the kinds of design questions that you should ask yourself when you're designing your inheritance in lab tomorrow and eventually in homework 3. Again, reminder, we're not expecting any inheritance. It's perfectly fine if you put inheritance in phase 1 on homework 2 for Friday. We're not expecting that at all, right? We're expecting encapsulation and abstraction in your class designs, okay? Any questions? Otherwise, you'll get more exploration tomorrow in lab, and then we'll continue this discussion as well as polymorphism on Thursday and next week. And then make sure to pick up your design document if you have not done so already.